Hey guys, welcome back. In this video, we're going to be talking about graphing logarithms. In our last video, we defined a logarithm as the inverse of an exponential function. So we have the function y equals 2 to the x graphed here, and its inverse function, f inverse of x, being log base 2 of x. And we graphed this function by first graphing our f of x function, then flipping all of our x's and y's to come up with this new function. But let's look at how we might graph one of these functions without doing that. So I'm going to start off with an example. So in this case, I'm going to graph the function f of x equals log base 5 of x. The first thing I want to do is identify the base. The base of this function is 5, and the input, I'm going to be looking at what goes into this function, and that is x. Now, when I'm finding the domain of my function, the input of a log function has to be positive. It must be positive. And when we look at this, log base b of y is equal to x. Well, what this y is y is equal to b raised to the x. B raised to the x has to be a positive number, so the input of a log must be positive. So to find my domain, I'm going to take the input and make it greater than 0. It can't be equal to 0. It has to be positive. So in this case, that gives me x is greater than 0 or 0 to positive infinity for my domain. Now I'm going to go through and I'm going to step through the rest of this. This domain restriction is going to lead to my asymptote. So I will have an asymptote at x equals 0. And I am going to graph that as a dashed line. You must always graph this as a dashed line with x is equal to 0. Now I need to come up with some convenient logs. And in this case, I'm going to use my base, or whenever I'm trying to do this, I'm going to think about my base. So convenient logs that I know. Log base 5 of 5. So what I'm thinking about here is I want to come up with an expression that I can use. So I know 5 to the 1 is equal to 5. That is an exponential. 5 raised to the 1 is equal to 5. So this becomes the base, the inside of the log, the other side. So if I have an input of 5, I will get log base 5 of 5, which I know to be 1. So I'm going to be kind to myself and come up with some convenient logs. So another log I know is 5 to the 0 is equal to 1. So this is log with a base of 5 of 1 is equal to 0. Again, using this relationship. 5 to the 0 is equal to 1. 0 is equal to log base 5 of 1. So my input here is 1. So this gives me log base 5 of 1. I know to be 0. Then I'm going to do this again. So I know 5 to the negative 1 is 1/5. So log base 5 of 1/5 is equal to negative 1. So this is my input, and this is my y. So now I'm going to go through and graph these. So I have 1/5 negative 1, 1 0, 5 1. And my graph is going to look like this. So as x approaches positive infinity, y is going to approach positive infinity. As x approaches 0 from the right, so that means as x is 0, gets close to 0, but is just a little bit positive, y is going to approach negative infinity. So my range here is from negative infinity to positive infinity. And this graph, if we turn it on its side, it looks just like an exponential equation. And so that's what we've got there. we're going to continue with another basic example, this time with a base between 0 and 1. So this was a base bigger than 1. Now I'm going to look at a base between 0 and 1. So in this case, my base is 1/8. My input is x. So my domain is the input is greater than 0. So my domain is from 0 to positive infinity. My domain gives me the asymptote, and I'm going to come up with my convenient logs. I'm going to start getting these convenient logs with some convenient exponential statements. So I'm going to start with some nice exponential things, and then I'm going to convert these into logs. So I know that 1/8 to the negative 1 is positive 8. So if I were to rewrite this as a log, I would get log base 1/8 of 8 is equal to negative 1. 8 is my input, so I have log base 1/8 of 8 is equal to negative 1. That's 1 point on my graph. 1/8 raised to the 0 is equal to 1. Log base 1/8 of 1 is equal to 0. So I'm switching those two to get my log expression. So my input is 1. Log base 1/8 of 1 is equal to 0. That's another point I can graph. Then I've got 1/8 to the 1 is equal to 1/8. So log base 1/8 of 1/8 is equal to 1. So my input here is 1/8 and my output is 1. If we look at these 3 points from each of our graphs, they're just the inverse of the 3 main points for our graph before, for exponential. So I graph my asymptote at x is equal to 0. I have the point 8, negative 1. 8, negative 1, 1, 0, 1/8, 1. And my graph looks like this. So I want to point out that the 3 main points we have are 1 over b, negative 1, 1, 0, and b1. Same thing over here. 1 over b, negative 1, 1, 0, and b1. These are just the flipped points of our exponential graph.